morning, everyone. I'm calling in from the West Coast this week, so still morning for me, even though on the East Coast we're getting in the afternoon. I'm Sam Winslow, Director of Business Development at Alsym Energy. We are a new battery cell chemistry, battery cell manufacturer, really with the key differentiating factors of being non-flammable, but yet still high performance and cost competitive with incumbent lithium-ion technology. Just real quick, I want to show you some of our leadership. So we're led by Mukesh Chatter. He's a serial entrepreneur, has built and exited companies in the telecom industry. Kripa Varanasi is our MIT connection from the Department of Mechanical Engineering. And then we also have representatives from RPI, Harvard, and industry executives like Mark Little from GE. So in the energy storage market, the situation is that demand is increasing across all sectors. And the fact of the matter is energy storage is never going to become a primary, renewables are never going to become a primary source of power until we have energy storage paired along them. So when the sun's not shining, when the wind's not blowing, you have to have a bank of energy that you can draw on so that we're not turning to fossil fuels. Lithium ion is the incumbent technology. It's great. It has high energy density, but the drawback is that it really doesn't have a suitable safety profile for all segments. And what we also see in the market is that there's demand for more longer durations across different markets. I'm sure you've also seen in the media lots of different lithium-ion fires. Like I said, I'm in LA this week. I'm looking out the window at a wildfire across the way. And just down the coast, there's another lithium-ion fire in San Diego, which is still burning. And, we also have fires with fossil fuels every day, which we deal with. And I'm not waving the red flag, stop everything. Lithium-ion is a challenge, but the fact of the matter is that we have to be really careful about where we're siting energy storage systems in urban or suburban centers, because you can have you can have problems. Even recently, the fire department in New York has spent over $1 million launching a public education campaign about the dangers of lithium-ion technology. So that's where we come in. We are a new chemistry that doesn't exist on the market today. And importantly, we are cost competitive with lithium-ion, even with recent price drops from overseas. Within the subset of non-lithium energy storage technologies, we have the highest performance across round-trip efficiency and energy density. And the really key factor is here is that we're inherently non-flammable. And what I mean by that is that our materials cannot burn. Some other aspects, we don't release any toxic gases, and that our materials are readily available from US free trade partners. Our first product will be Alsym Green. This is targeted towards the stationary grid storage market. It'll have an energy density of 3.4 megawatt hour in a standard 40-foot container. Yes, that is less than lithium ion, but it's higher than all other lithium ion alternatives. And that'll be available Q1 of 2026. Of course, we're always looking ahead to future markets too for marine and mobility. Just a few other things to highlight about that first product, Alsym Green. So I said safe, stable chemistry. We're not using lithium. We're not using cobalt. We're not using nickel. All of our materials are readily available. And again, the key factor being we're non-flammable and non-toxic. Our battery form factor looks like a lithium-ion cell, is built like a lithium-ion cell. So as we scale, we can use all that existing lithium-ion infrastructure just without the considerations for dry rooms, fire locks, worrying about dangerous solvents. Everything that we do is processed in water. And then looking at the battery energy storage system itself, cost competitive, high performance. There are some specs. The 1.7 megawatt hour there is in a 20-foot container format footprint with 92% DC round trip efficiency. You can also configure the system for short duration, medium duration, long duration. So as you see demand for intraday and intraday storage, our batteries are capable of that. Over the past few years, we've been focused on prototyping and scaling up our sampling. So we have a sampling line coming on end of this year, and then in 2025 we'll be scaling our commercial production. The ask for you all today is we're seeking partners. So we're working towards our first system pilots in the field, both grid scale as well as residential. So we need we're the battery cell manufacturer, but we need partners for integration, for project developers, OEMs. And then we also need off-takers. So whether it's utility, data center, heavy industry that want to pilot a novel battery chemistry and technology, please reach out. My email is there at the bottom. Reach out today. We have a couple colleagues at an energy storage conference this week in LA. So maybe there's opportunity to set up a meeting today. Thank you very much.
Thank you, Sam. As questions come in, let me ask you, you mentioned pilot field tests. What kind of size are we talking about?
So if we're talking utility scale, that would probably be one container to start, but with plans to scale out to multi-megawatt hour. But also for the residential scale, think like a Tesla Powerwall size unit. So 10 kilowatt hours, something to power a home.
Okay. Again, a reminder to post your questions to the Q&A chat tab at the bottom of your screen. Sam, also, could you tell us more about the use cases for utilities, data centers? Data centers is also a key word coming up, and heavy industry, for example.
Yeah, so everyone needs energy, and if you're paying high prices during the day and peak loads, it would be great to have a bank of energy there that you can draw on when prices are high, so that you're not paying that expensive cost, or you're not causing the grid to turn on fossil fuel utilities like peaker plants, which are high power but high emissions.
And can you talk a little more about what the chemistry is?
Sure. So it's still proprietary, but what I can say is that our electrodes are mixed metal oxides, and then our electrolyte is water-based, so water with salt. Compare that to lithium ion, where you have a flammable liquid.
Okay, thanks, Sam. More questions coming in, so we'll put them in the chat.